All right, this is Mr. Wyrick. I'm going to go over this review with you just a little bit. I'm not going to put all the answers on here because this is just calculator heavy. I don't think you need to see me type on the calculator forever, but remember, all of this stuff is going to be based around our SOHCAHTOA, our trig functions. So I'm going to be referring to this up here a lot. On this one, find the missing side. Here's my angle. This is opposite. This would be my hypotenuse. So this one's going to be the sine of 15 is equal to my opposite over my hypotenuse. This one, I have this angle. Here's my opposite side. This is going to be my adjacent. So this is cosine of 56 is equal to x over 16. Remember, when the x is on the bottom, you swap these when you type it in. When the x is on the top, you just multiply by this, but make sure it's out front. This would be 16 times the cosine of 56. This over here would be 12 over the sine of 15. Make sure your calculator's in degree mode. Work your way through those. On this one, we have 70. This is the opposite. This is the hypotenuse. So the sine of 70 is equal to x over 13. On this one, there is no opposite side. There's adjacent. This is hypotenuse. So this is going to be the cosine. Oh my gosh, did I get this? Yeah, I got this one wrong. This is opposite adjacent. This wouldn't be cosine. This would be tangent. Hopefully you saw that on the video and you said, nope, that's tangent. Okay, so cosine, this is adjacent, this is hypotenuse. So the cosine of 62 is equal to 17 over x. On this next one, we've got our angle here. This is opposite, this is hypotenuse. So this is, again, sine of 67 is equal to our opposite of 15 over hypotenuse of x. This one here, we have opposite, we have adjacent. So yes, tangent here. The tangent of 28 is equal to our opposite side of 13 over our adjacent side of x. And again, all that's right here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Down at this part is the exact same thing. Here's my angle. This is the opposite side, this is the hypotenuse, this is sine. But it's the sine of the angle that we don't know is equal to my opposite over my hypotenuse. So this is going to be, I put in arc sine of 27 over 31. This one is adjacent hypotenuse, so this is going to be arc cosine of 14 over 34. Remember, put that in parentheses. Make sure you're in degrees. Oh, can't scoot it with the cup in the way. This one is opposite adjacent, so this is arctangent of 11 over 40. This one here is going to be adjacent hypotenuse, so this is, again, arc cosine of my adjacent side of 28 over my hypotenuse of 51. As we continue on the second page, the back for me, this is adjacent hypotenuse, this is arc cosine, COS. This one we have all three. And I believe, yeah, 13, 14, 15, 16, they have all three sides. So you can decide what you want to do here. I could do arctangent, I could do arcsine, I could do arc cosine. It would not matter which one I do as long as I set it up for the correct angle. So just be kind of deliberate here. Sorry, this one's also adjacent hypotenuse, so this is also arc cosine. So then down here at the bottom, find the length of the side labeled x, round intermediate values to the nearest tenth. Use the rounded value to calculate the next value, round your final answer to the nearest tenth. This is actually a little bit more complicated than anything that you'll have to do on the upcoming performance task. So I wanted to give you something that would stretch you a little bit. So what's happening here is they give me this 6, they give me this 30-degree angle, and they say, hey, if I put this down through here, we have a right triangle. So then I can use that information to calculate this one. Well, what I'm going to need is this shared side. So that would be my adjacent side for this, and this is my hypotenuse. So I would need to do the cosine of my 30-degree angle is equal to my adjacent side of x over my hypotenuse of 6. So in this case, it's going to be 6 times the cosine of 30. That will get me this side here, which we will call side A. Now for my 44-degree angle, this is my opposite side. This A would be my adjacent side. So that's going to be tangent. So the tangent of my 44-degree angle is equal to x over whatever I get for A. So I use 6 cosine of 30 to get my answer. I'm going to round that to the nearest tenth. I'm going to put that here for A. And then I'm going to use that to solve this next part for x. I'm also going to round that to the nearest 1 decimal place. Okay, so again, on this one here, I have my hypotenuse. I need my adjacent side. So that's going to be cosine of my 26-degree angle is equal to my adjacent A over my hypotenuse of 48. So when I solve that, that's 48 times the cosine of 26 is equal to A. I'm going to round that to 1 decimal place. Then from this, that's actually going to be my opposite side over my hypotenuse. So this is the sine of 41 is equal to A. That opposite side, the 48 times the cosine of 26 is going to go there. And I'm going to put that over X, which is the hypotenuse there. Okay, so all of these are going to be 2-step like that. If you'd like, go ahead and pause one, try to set up the next couple, and then check back through here. This first one, 38, this is opposite hypotenuse. So this is going to be the sine of 38 is equal to, we'll call this O this time, over my hypotenuse is 17. So that's 17 times the sine of 38 is equal to that O side. Then this angle, this is going to be this and this. That's opposite adjacent, so this is tangent. So the tangent of my 25-degree angle is equal to my opposite side of x over the O side, which this is O, that's this right here. Okay, then the last one we've got here, shared side. This is my adjacent, this is my hypotenuse. This is going to be cosine of 26 is equal to that A over 37, my hypotenuse. Then from here, this is opposite. I have adjacent over here. So the tangent of that 70-degree angle is equal to my opposite side of the A over the X, the adjacent side that I have there. So again, this is that A is going to be 37 times the cosine of 26. I round this to 1 decimal place. I put that right here where this is, and then I use that information to solve the next piece. Hopefully this gets you in the right frame of mind. There's going to be 2 more questions on there that you need to kind of look at. I'll have it written on the board. That's the, what is the definition of a segment bisector? What is the definition of an angle bisector? Make sure you look back through the notes and get those back down. That should put you in a good spot to get your way through the performance task.